Hi everyone, this is Maverick Paul, the Chemistry Guru. Now in this video, we want to discuss the suggested solution for 2020 A-Levels H2 Chemistry Paper 1, question 28. Now question 28, the use of the data booklet is relevant to this question. A current of 20.0 ampere flows through a dilute solution of sulfuric acid for 3.00 minutes. So the question is asking how many moles of oxygen gas are released at the anode during this time. We have 4 options A, B, C, D. So later when we run through the calculation, we will be able to compare this with our answer. Now, the topic tested in this question, of course, will be on electrochemistry, more specifically involving electrolysis. What we have to determine first thing is, what is the reaction that is taking place? Actually, the question already tell me I am forming oxygen gas as the product. So probably involving sulfuric acid. Between sulfate and water, we know that sulfate will not be taking part in the oxidation at the anode. It should be water, but just for the sake of concept, let us run through this idea and we can actually determine between my anion and water, which one is more likely oxidized at the anode. So involving concept-wise, the anion will migrate to the anode to be discharged. And since this is in aqueous medium, we will have to consider the oxidation of sulfate, oxidation of water, and I will have to refer to the data booklet and choose the relevant half equation and make use of the E value to do comparison. So if I consider oxidation, alright, involving sulfate, involving water, species that undergo oxidation should appear on the right hand side of the half equation, because all the half equations in the data booklet are all reduction half equation. So species on the left hand side will undergo reduction, species on the right hand side will undergo oxidation. So when I refer to the data booklet, I just need to focus on the right hand side of the half equation and look out for my SO4 2-. Involving sulfate, I think this is easy. There should only be one of them. SO4 2- on the right hand side, S2O8 2- on the left. E value, it is a plus 2.01 volt. So this is the one that we will be using involving sulfate. Now involving water, if we refer to the data booklet, the half equation where water is on the right hand side, we will have 2 of them. The first one is involving water oxidized to H2O2. The other one is water being oxidized to O2. Now, between these two, which is a more likely candidate, what we can do is we can consider the stability of the product that is being formed. Because if I consider oxidation state for oxygen, more common oxidation state for oxygen will be 0 in element O2 or -2 in many other compounds. Most of the other compounds involving oxygen, oxidation state for oxygen, usually it is a -2. If it is common, it will mean that it is stable. So the more stable the oxidation state, we will see this in a lot more examples, so the more common it will be. And therefore, we know that oxygen actually likes to either form 0 oxidation state or -2 oxidation state. And if I consider -1 oxidation state, it is not common. We probably can only think of hydrogen peroxide as an example, where the oxidation state for oxygen, it is a -1. So it is suggesting to us that -1 oxidation state for oxygen is actually not very stable, and therefore it is not common. So if I consider oxidation of water, water will not spontaneously undergo oxidation to form hydrogen peroxide. The oxidation of water to form O2, it is a much more reasonable, much more likely outcome. Again, maybe for this exercise, because the question tells me that O2 is formed, so in terms of comparing, it is pretty straightforward. We know that we should be using this half equation involving the E value plus 1.23 volt, but we just want to run through the concept and we can actually systematically rationalize which is a likely product that we should be using and which is a likely half equation that we should be choosing. So involving oxidation of water, actually water oxidized to O2 is much more likely to happen as compared to water oxidized to hydrogen peroxide, because hydrogen peroxide, it is not a stable oxidation state involving oxygen. Now, when will we use this half equation involving the plus 1.77 volt, it should be the other way around, involving the reduction of H2O2 to form water, then we will use this half equation. Okay? So we should be now comparing between these two half equations involving my SO4 2- versus your water, plus 2.01 volt versus plus 1.23 volt. Now if I consider oxidation, which of these species will be more likely oxidized? The one with the more negative inert value, correct? So if I consider my water 1.23, it is more negative than 2.01, and therefore it means that water is more likely oxidized. So therefore water will be discharged at the anode. So the oxidation taking place at the anode in this case will be 2 water to give me O2 plus 4H plus 4 electron. And the half equation is here, and we have written this explicitly here. Once we have this half equation, what we can do is we can try to calculate the number of moles of O2, because we already know which half equation to use. So the current of 20.0 ampere and the duration is 3.00 minutes. Of course, what we need to do is we need to make use of the Faraday's equation. First, starting with this Q equals to IT, charge equals to current times time in seconds. So the current is 20.0 ampere, time is 3 minutes. I need to multiply this by 60 to convert it to seconds. So I'll get this 3600 coulomb. The next Faraday's equation that I can use is charge equals to Faraday's constant multiplied by the number of mole of electron. So I can solve for mole of electron, which is Q divided by Faraday's constant, 3600 divided by Faraday's constant 96500. I'll get this value 3.731 times 10 to the power of minus 2. Then once I find the number of mole of electron, I can compare mole ratio using this half equation, correct? I can compare mole ratio involving my electron to O2. So the number of mole of O2 to electron, based on what I have here, is 1:4. So mole of O2 to electron is 1:4. Using the oxidation half equation, then I can find the number of mole of O2, 1/4 times mole of electron. I just sub this value in, I'll get my answer 9.33 times 10 to the power of minus 3. So once we have calculated this, 9.33 times 10 to the power of minus 3, I can run through my options A, B, C, D. The answer to this exercise obviously will be option C. Alright, so that was the discussion involving this exercise. If you have learned something useful from this video, please give me the thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.